Hey everyone, welcome to the demo for my CS767 project. In this project, I wanted to create a bot that would improve its ability to play StarCraft by using machine learning. The idea was to first generate a bunch of training data by having a bot that chose random actions play against the game's base AI. From these games, I saved data based upon 15 metrics that would be recorded every second or so. These metrics included things that I felt were key to giving the bot an idea of the current state of the game, like its amount of resources, how many soldiers and worker units, the total number of buildings in a few different categories, and finally a score for the total value of enemy structures and units who've been killed. Since the game is very complex, consisting of hundreds of different possible types of actions, I boiled it down to 9 actions the bot was able to take. Attack, build assimilators, build offensive forces, build pylons, build workers, distribute workers, do nothing, expand, or build offensive buildings. This simplification would obviously severely restrict the bot's overall strategy, so I filled in some of the blanks with code that would cascade depending on the state of the game. An example of this is the build offensive buildings action. Since specific types of buildings must exist before others can be built, when this action was called, the bot would first make a check to see which buildings already existed, and then choose the appropriate one from what is available. Every time an action was successfully carried out, it was recorded and saved out with the game's current state data. All of this data was written to a NumPy array at the end of the match. I built a few virtual servers on Google Cloud Platform and then set them up to play multiple instances of the game concurrently. With this setup, I was able to generate data from thousands of games in a short period of time. Since my overall goal was to use machine learning to improve the bot, I decided to use a special kind of recurrent neural network called LSTM, or long short-term memory. This type of network operates best on time series data through a step function, as it retains information from previous steps while continuing to feed itself new information in a circular pattern. This architecture is similar to how the bot is set up to function within the game itself, so I thought it would be a great fit. Once the neural network was constructed, I trained the model and implemented it back into the bot. I removed the element of random decision making and set the model up to evaluate real-time data being produced by the game to choose an action from the 9 listed previously. Unfortunately, the model did not live up to my performance expectations and often becomes stuck choosing the same action for long periods of time before it is destroyed by the AI. I made several changes to the overall architecture and hyperparameters of the network, total number of layers, node configurations, etc., with no noticeable improvements. Next, I tried generating new data from a bot that followed a more structured decision path than the random bot, and also only included data where the bot won, but to no avail. To truly improve its gameplay, I believe the data being collected or the frequency of the collection needs to be scrutinized, or perhaps further simplification of the number of actions available for the bot to choose from. While the bot only wins a match from time to time, this project was a tremendous learning experience in a wide variety of tools and technology, and overall very fun to work on. Thank you for watching.